Today we're going to look at the sandwich theorem. It's also called the squeeze theorem. Either one is fine. Depends on the author of whatever textbook. And what it says is this: if g of x is always less than or equal to f of x, which is always less than or equal to h of x, for all x not equal to c in an interval about c, and the limits of g of x and h of x as x approaches c are both L, then the limit as x approaches c of f of x also has to be L. I think a picture is helpful on that. So what's happening is this. We have some point C. And g of x is always on top. Don't know what it looks like, don't really care what it looks like. And, all right, sorry, that would be the one on top. That's going to be h of x. H of x is always the biggest one. And g of x is always smaller than that, but it goes to the same point as x goes to c. It goes to this point. Now, might there be a hole there? Yes. Again, we don't care what happens at c when we're finding limits. But finally, what we have is f is always in between those two. Well, if it's always in between those two, it gets squeezed in between the two, or it is sandwiched in between the two, so that at x is equal to c, it has the same limit as the other two. This is helpful for proving certain limits. Now, a lot of these limits, honestly, I look at them and I know, I'm like, yeah, done. I don't have to think about them very much. But if you're trying to show what the limit is, the squeeze theorem can come in handy. So, for example, and this is where it says, show that this limit is 0. So they're telling you what the limit is. They're just saying, all right, you've got to show that this limit is equal to 0. And frankly, most of the examples that we're going to do are going to involve sine or cosine. And the reason for that is because it makes these pretty simple. Because what are the upper and lower bounds on the graph of sine or cosine? 1 and -1, exactly right. So that means that if I replace this with -1, I can say x squared times -1 is always going to be less than or equal to x squared times sine of 1 over x, which is always going to be less than or equal to x squared times +1. And that's true for all x, provided that x is not equal to 0, because at 0, sine of 1 over x doesn't exist. So now what I want to do is take the limit as x goes to 0 of x squared times -1, and that's 0, and the limit as x goes to 0 of x squared times 1, and that's 0. Therefore, since those are below and above the function I'm interested in, at 0, and that other function is in between the two, it gets sandwiched or squeezed in between the two, that limit has to be 0 also. The limit as x approaches 0 of x squared times sine of 1 over x is also equal to 0. Now, in terms of doing these problems, most of the time you would just look at that and go, well, sine's just going to oscillate back and forth between -1 and +1, so I don't really care that much about it. X squared goes to 0. This has got to go to 0. All right, so the squeeze theorem also applies for limits as x goes to plus or minus infinity. So here, again, sine of x is bound by -1 and +1. So I can say -1 over x is less than or equal to sine of x over x, which in turn is less than or equal to +1 over x. The limit as x goes to infinity of -1 over x is 0. And the limit as x goes to infinity of 1 over x is also 0. Therefore, the limit as x goes to infinity of sine of x over x has got to be 0 because it's squeezed in between the two. For our purposes, if you got a problem like this on a test or a quiz and it said find this limit and you showed no work whatsoever, that would be fine with me. Because I look at that and I go, okay, sine always has finite values. Something finite over something infinite is going to go to 0. I would be just fine with that. If, on the other hand, it says show, or show the analysis that leads to your answer, then you got to use the squeeze theorem. Okay? Any questions about that? Probably the shortest lesson we'll have all year long.
Do they have to be like the same distance apart? Like, does it have to be -1 and 1? It could be like -2 and 1.
It could be -2 and 1. It just, most of the examples we have aren't.
Okay.
Most of them are symmetric. But it doesn't, it's a great question. It absolutely doesn't have to be. Could be, but no big deal if it's not. Any other questions? Okay.